Good morning, everyone. In this occasion only, I want to deliver my presentation of paper that the title is Synthesis and Characterization, Polyglycerol Malate or PGM modified with 1,4-butanediol. This is the outline of my presentation that is comprises as 4 parts as follows. This is the first of my outline presentation. Plastics are ubiquitous and considered as versatile materials. Plastic have served its parts in many aspects of human life. It has been used for many purposes, for example, kitchenware, household, packaging, bottle container, and piping material. Comparing to other kinds of materials such as glass and plastic, such as glass or metal, plastic are relatively lighter. They are also relatively cheaper. However, its properties exhibit excellent properties, such as resist to extreme condition and resistance to corrosion. Plastic can be used many times and reshaped for the same or different purpose. However, durability of plastic may encounter some issues. We frequently encounter the use of unnecessary plastic bags. Currently, plastic fabrication from petroleum derivatives sometimes include toxic chemicals. Plastic for bottle packaging are often found for single purpose, and this makes plastic waste to accumulate in landfill can be released to environment. So, future plastic management should be done by the use of plastic properly, creating processing involving eco-friendly raw materials, strong awareness for recycling, and create biodegradable plastic that can be recycled or composted. Different plastic materials released to marine environments can break down longer, and even most of them degrade more than 100 years. This issues this phenomenon called marine debris. And this bar chart shows 3 classes of plastic encountered as waste. It can be seen that plastic waste generation dominantly derive from ones that are sometimes recycled and others never been recycled, and just fewer portion that can be recycled. Aforementioned issues made biodegradable plastic are critical things to realize. To make it affordable, we must think its sustainability for a long-term period. Bioplastic derived from non-toxic chemicals. It should be inexpensive. It must retain the same quality with current plastic and can be recycled. Glycerol is regarded as one sustainable feedstock realistic for future, since its availability will increase due to the increased amount of biodiesel production that replace fossil fuels. Glycerol is easy to break down due to its higher OH group contents. Since being provided as waste or side product, the glycerol price is more economical and bioplastic production will gain profit. However, some obstacles need to solve, such as how to purify glycerol to meet certain degrees of purity, how to make glycerol-based plastic be reused many times, since most of them are thermoset, and how to design certain properties that meet certain demands. To classification of plastic with its advantages and disadvantages and how to design material that emerge to, the, to image the advantages for both will be a good objective to realize. Scientists have strived to create plastic that meet the purposes, such as the success of Cuban to produce tray-leaf plastic by combining major parts of thermosets with minor parts of thermoplast. In another work, Zhang and co-workers successfully created high molecular weight PBF using 1,4-butanediol and fumarate acid through two-step mechanism processing, melting, and followed by polycondensation. Then, Navarro and co-workers successfully make combination of glycerol and diol to be possible during synthesis of modified PGA prepolymer, also with the same mechanism. Finally, Wang and coworkers successfully created PGM polymer by inspiring PGS prepolymer synthesis conducted by other research teams. Based on this state-of-the-art, there is a strong desire to enhance properties of PGM by increasing its molecular weight with not to throw away its dry PDA. To realize 1,4-butanediol, one of inexpensive diol is selected to proper polycondensation of malic acid by adapting with the same mechanism. So, how to synthesize prepolymer? Prepolymer synthesis is done by mixing 0.6 mol malic acid with its 0.3 mol glycerol and butanediol in 500 ml flask, processed at 160 to 180 Celsius degree for considerable time under nitrogen atmosphere. Lower temperature is more convenient to hinder possibility to cross-link. The reaction is continued to lower pressure around 400 to 900 millitorr until considerable viscosity attained. The prepolymer produced with structure similar to what Navarro and co-worker created. Prepolymer is further processed into foam using slot die cutting and continued to thermal curing under the same temperature and low pressure for 8 hours. To perform thermal curing, the prepolymer needs to dissolve into GHF as a solvent. And then, to assure the success of works, several tests will be done as follows, including molecular structure elucidating, molecular weight and polydiversity index measurement, mechanical properties, hydrolysis tests, degradation tests, and water updates. The successful of reaction can be observed through functional group among fingerprint and diagnostic region, as we can see from the works conducted by Navarro and coworker in synthesizing PGA prepolymer. All spectra show sharp and strong peaks at 1750 correspond to carbocyclic stretching. Furthermore, typical aliphatic CH absorption peaks appears at 2670 and OH stretching is observed as a broad peak at 3500. The modified PGM prepolymer, besides showing these particular peaks, also exhibits double bound C stretching around 2250 to 2100. Its NMR spectroscopy elucidated by predicting among the position of hydrogen atom in molecules. Its NMR spectra will exhibit several peaks, indicate that the location of hydrogen in molecular structure, and so the molecular structure and phenomenon exist during the synthesis can be studied. GPC analysis is conducted to measure the molecular weight of prepolymer and also its polydiversity index. As the results performed by Wang and coworker, the PGM prepolymer shows its low molecular weights, around 943 for Mn and 1507 kilodalton for Mw, and good polydiversity index. Modification of Mn and Mw and retain strike PDA is need to be done. The prediction by addition of 1,4-butanediol due to the result from previous work conducted by Chen and coworkers to synthesize prepolymer and succeeded to obtain around 75 kilodalton for Mn and 1.98 for PDA. So this is the mechanical properties result from PGM and PBM as comparison. It can be seen that PBM has poorer Young modulus and tensile strength. On the other hand, it shows higher elongation at bridge because of its elastomer properties. The PGM polymer shows better Young modulus and tensile strength and poorer elongation at bridge. The PGM prepolymer modified by 1,4-butanediol will have partially elastomer properties like PBM and will enhance the tensile and Young modulus of PBM produced. This is the result for hydrolysis test. The hydrolysis test under sodium hydroxide solution for PGM and PLA as comparison. PGM film degrades faster and breaks down for 48 hours. However, PLA does not show to degrade. A longer aliphatic hydrocarbon change due to 1,4-butanediol in molecular change of modified PGM prepolymer will reduce hydrophilicity. However, due to the ester bonds in polymer molecule, the PGM film derived from modified PGM prepolymer will also show higher direct degradability under sodium hydroxide solution. Different aquatic environment is used to measure degradation of PGM film. RO defined as RO water, pH 6.2 to 6.4. Freshwater from aquarium, FA, pH 7.5 to 7.6. Tap water, TW, pH 8 to 8.1. Seawater from aquarium, SA, pH 7.9 to 8.1. And artificial seawater, SW, pH 8 to 8.1. The table features degradation profile of PGM films up to 56 days. It is revealed that the PGM film degrades faster. 2. The salinity of waters that accelerate degradation. As we can see the results from SA and SW. PGM film from modified prepolymer will predict to have the same behavior. Because of ester bonds present in its molecule, it will be slightly lower than PGM film from unmodified PGM prepolymer. Here the water uptake test results for PGM film derived from unmodified PGM prepolymer. Water uptakes are slightly higher to tap water than seawater environments. Water uptakes in seawater eventually reach around 25%, much higher than in RO and TW. These results indicate that the presence of salt appears to have slowed the water molecule entering most of the prepolymer film initially, but eventually increased the water absorption ratio of the polymer longer periods. Since PGM is a network polymer with hydroxyl group throughout, it is likely with inclusion of metal cation, more water molecules are transported into a bulk polymer, leading to higher water absorption. Natural aquatic environment SA and FA tends to present larger amounts of microorganisms, leading to artificial ones. Under SEM observation, the presence of microorganisms living in aquatic environment is clear to show. Aquatic environment obtained from more natural resources contain larger amount of microorganisms. The surface of PGM film were altered by a considerable number of microorganisms and may be assumed that microorganisms may share part in degradation process. And as a conclusion, PGM prepolymer can be successfully synthesized through a facile procedure from glycerol and malic acid by adding 1,4-butanediol to enhance its properties. This procedure can be further optimized by increasing and lower the percentage of 1,4-butanediol in order to satisfy the feasibility of commercial production. Alright, I think that's all my presentation. Thanks for watching.